Yep, nods at the back. Yeah, okay. Hi everyone, my name's Amy Boyd. I'm a cloud advocate at Microsoft. I specialize in machine learning and AI. AI is so broad, so we'll keep machine learning there for a little bit. I get to work, quite a lucky job really, I get to work on some of the latest technologies that come out in these spaces. I get to work with developer and data science communities to basically do a lot of learning pieces, get people onboarded with technology, and start to explore what we can do with platforms such as Microsoft Azure. Today I wanted to talk about it's a short session, past, present and future of ethics in AI. I want to share with you a little bit some of my past and some of the stuff I did in academia, and actually looking back on it, thinking I was well ahead of my time. And then also the present, so how does that relate in the same context to some of the stuff we see right now, as we've been hearing what data fuels these problems. And then finally, I had an amazing chance to talk to a lady named Hannah Wallach, who is part of our FATE organization at Microsoft, which is Fairness, Accountability, Transparency, and Ethics. I got a chance to speak to her very briefly, and she gave me some great pointers on how we can move forwards and some of the stuff that they're researching, so I'd love to share that with you. This talk's going to mainly focus from someone like myself's point of view. So I was wondering, is anyone in here a data scientist? Cool. Developer? Cool. Machine learning engineer? Yeah, that's a strange one. That's a very specific one, isn't it? It is quite different to a data scientist. So I'm gonna share with you a story. Can anyone tell me who these people are? Does anyone recognize these people? James Arthur, yeah, so James Arthur's in the middle. He's released countless albums, had many number ones. We have, it's a descriptive thing. Ella Henderson, she's also a singer. She's had a few number ones back in the day. I was quite a big fan of Ella. Anyone recognize this gentleman here? Rylan Clark. He's now a very big member of the This Morning team, if you get a chance ever to see daytime TV. I'm actually informed by my brother-in-law that Lucy Spranagan, down at the bottom, she's actually from Sheffield, which is where I went to university, so Yorkshire lass, and she does some really, really cool things. But she is actually still touring in some of the small pubs around Sheffield. Can anyone tell me where all these people potentially met? What do they have in common? This is like, have I got news for you? The X Factor, yes. So in 2012, all of these people were taking part in our very popular TV show called The X Factor. I was a big fan at the time. I'll be honest, I've not watched recent series. I've kind of gone off it a little bit. But at the time, I was a huge fan, and I was actually at university. I was doing some academic research, and I was specializing in machine learning. I actually got a chance to work at our search engine, Bing, for a year, and I was seeing a huge rise in social media. And at the time, Twitter was like at its peak. Twitter was going crazy, and that was the place where everyone was having conversations. It's kind of getting more like just tech and politics conversations now, but we'll keep our opinions to ourselves. So basically, I went up to my academic sort of research tutor, and I said, here's a proposal for you. I'm going to call it the Twitterati. Does anyone know what Twitterati actually means? Who are the Twitterati? No, it's a weird one, isn't it? It does actually come up, but the minute you Google it, it has a full-on meaning. Users of Twitter, especially those who frequently post and have a large number of followers, think Katy Perry, think Justin Bieber, think Barack Obama, think these types of people. They're actually part of something called the Twitterati, and they're very influential in the way that they talk and the way that they share things in social media. So I basically said, I want to bring these two things together. My supervisor must have just been like, why do I always get the crazy ones? Like, why can't she just do what everyone else does? But I decided that this was my thing. This was what I was going to do. I was going to, given Twitter data, try and predict the outcome of the X Factor, given past data on what people were saying about the contestants. Let's be honest, the X Factor, as much as it's a singing contest, is a popularity contest. And what do people like to do on Twitter? They like to share their opinions on other people more often than not, or opinions on an item, or opinions of some kind of sense. So where does the actual machine learning, where does the academic research come in? Well, there is. There was actually quite a lot of complexity to do this. There's two phrases. At the time, I had to create a sentiment analysis classifier. So I had to do whether a tweet was positive or negative or not. And I wanted to learn from domain-specific data. This was something at the time that wasn't massive. We could do general sentiment analysis. We could say, this is good and this is bad. But what we couldn't do was understand that actually when someone says, when you're down with the kids and someone says, that's sick, it doesn't mean it's bad, it actually means it's good. Or when actually the word music shouldn't be classified as positive in this case, because music was in all of the context in this domain, so it's actually neutral. So there was this weird thing between the domain understanding and the actual positive and negative sentiment. So I built a classifier, and this was machine learning technologies. And then I wanted to rank my contestants. Well, having worked at a search engine, ranking is a huge machine learning problem. Being able to rank different items on relevance or rank them on popularity or something like that can actually be measured. There's many different formulas and algorithms around that. So what did I do? Well, when I look back at it yesterday, goodness me. Oh, do you have to actually press play? Sorry. Oh, I see. It's literally just scrolling, but don't worry. That's awesome. There is literally just endless measurements and all of these accuracy measurements we talked about and all of the different experiments that I did, all the algorithms I used, all the feature selection I looked at, all of the different data set SKUs that I looked at. It was very, very interesting to see that actually the first part was heavy, heavy machine learning. But what came next, I guess, is the interesting piece. Well, many people ask me when I talk about this, say, well, did it work or not? Like, did you predict the outcome of the X Factor or not? And I was like, well, it actually did all right. It did okay. And I'm going to actually dive into some of the reasons why it maybe didn't do okay. But I actually, given a support vector machine, so those in the room will know that that is kind of like hashtag old school, because no one talks about SVMs anymore. It's all about neural networks. And I also used domain-specific data, and I could rank the minute the contestants went along too much. It was very, very hard to rank them. So sort of 6 contestants and less, I was actually able to rank correctly. I was able to predict who would win each week on the biggest amount of votes, and who was going to get sort of eliminated as well. I looked at all of the different technical sides of it. So I looked at many algorithms, many features. I looked at stop lists to remove weird punctuation in language. Language is hard. Language is not something that is really easy to interpret all the time. And I also looked at all of the different types of ranking algorithms. But what was the most exciting part? So I have pages of these things, pages and pages. And I did all of this technical research. And then I actually started to keep looking. I just kept looking at all of the data. I went off the algorithms. They were all just doing fairly similar things at the time. Deep learning wasn't a massive thing. I wasn't going to apply that. And feature selection, I was nitpicking different things. And stop lists, it was like, do you want emoticons in there? Do you want and the in there? And I was like, there's so much more to this. There's actually a story behind this data. So actually, interestingly, the topic that I chose meant that I investigated the data more because I've lived that scenario. I am the one, I didn't tweet, I'm more of a consumer than a sort of actually write on there, but I am the one that would share my opinion on, the next day in class on who had done well in the X Factor, who had been rubbish that week. Oh my God, weren't you absolutely destroyed by the vote? How did everyone vote that way? How did that person get eliminated? So I dove into the data because I was interested. So that's quite interesting, right? That wouldn't have necessarily been the case if it had been the COCO data set or the MNIST data set or the basic research data sets. It was interesting to see that this was something that was really like something that I was interested in. So I found some findings that were actually data specific, and I actually want to show you some of the biases that live in such a simple data set. It's about the X Factor. Hopefully no one gets harmed in the making of the X Factor, but there's lots of interesting stuff here. Twitter data has a bias of its own. There's a lot more positive data in these domains than there is negative data. As much as we see many, many trolls online, and we'll get to that in a minute, that in most cases there was a lot of positive data to mine. I actually mined the data by using emoticons. It was one of the easiest ways in such a short 140-character long thing to say if someone put a smiley face or a sad face or a crying face, it would reflect what was said in the statement. Many things wrong with that. We can get into that later. But the key thing there was actually I had so much more positive data with smiley faces, data with laughing faces, data with music icons, stuff like that on it, than I had with negative. I think it was about 70-30, but I can't really remember, and I'm not sure I actually wrote it. I was scanning my research the other day. So I started to do, I saw this bias, and I saw that my negative classifier was never as good as my positive classifier, right? I had less data. I had less to learn from. So it was always less, and I was like, oh, it's really bringing down my accuracy average. So what am I going to do about it? Well, what if I just said, right, 50-50. I'll use less data, but I'll use very 50-50 classes. And then I said, obviously, we need to do some more testing, right? So then I did 60-40 as well in the direction of positive because I knew that the natural incline was positive. Interestingly, NB stands for naive Bayes. Naive Bayes is a very basic classification algorithm, and SVM is support vector machines. So those two were different types of algorithms. The SVM always performs slightly better. It's better on text data, we know that. But one of the interesting things is the 50-50 split was always slightly less accurate, technically. And I couldn't quite explain it, because I was like, well, now it's got enough data, what's wrong with it? Well, interestingly, I guess in real life, there still is a natural skew to the data, and 60-40 seemed to land quite well. So I don't know if I ever got to the bottom of this. This was an interesting one. So if anyone has done stuff in this area, I'd love to talk to you about it, because I do remember being quite confused at the time. Let's talk a bit about Ella. Let's see what time we're on. Okay. Let's talk a bit about Ella. Ella was like one of the favourites to win. Everyone loved Ella. I loved Ella. I wanted her to win. And in about a week, she was quite close to the final, but she wasn't. And she was like the bookmaker's favourite. Everyone was gunning for her. And the week that she went out, I spotted in the data that she had, because I was testing who had the top sentiment and who had the more negative sentiment, who was going to get voted out. And Ella came up at the bottom for like one of the weeks, and I was like, that's weird. I do remember there being a big outrage about it, like, oh, why did Ella go? She was awesome. All these other people can't sing. All of these types of comments. And actually, it was super interesting. So I dove into that bit of the data, right? I sectioned off my tweets from that week. And interestingly, her negative score was 2,503 negative tweets and only 571 positive and a few neutral. And I was like, gosh, that's a very unusual split. If we then looked at all her weeks before that, it was very, very different. So I was like, well, what's going on here? Well, interestingly, right, the top one was massively skewed because actually it was for the whole show. I chose the tweets from the Saturday and the Sunday show. This is when X Factor got big. And it wasn't just a Saturday night. It was like your whole weekend taken up by the X Factor. And actually, a lot of the negative tweets were saying, hey, like, why has Ella gone? This doesn't make any sense. Like, this is crazy. You people are rubbish. X Factor's fixed, and all of that kind of stuff. So I actually removed the Sunday night, the night she got voted out. No one knows she was leaving yet. I removed all those tweets. She still had a negative rating. People were still tweeting saying, God, you're boring. This is so unfortunate. Love the song, but Ella ruined it. She made it a ballad or something like that. And I was like, she was meant to leave. People didn't like her. They liked the personality. They liked her all the previous weeks, but that week she didn't do as well. And I just thought this was super interesting because I was like, gosh, the skew in the data over the date time thing was very interesting, right? Something that populates your data by accident and you don't realize it's in there can massively skew the outcome of what you're expecting. So this massively skewed my rankings for 1 week. But also people were saying, like, oh, I'm outraged. And it's like, well, you weren't outraged 20 minutes ago because you were tweeting that she was boring. So, yeah, guys, I have the data. Okay, who's up next? Christopher Maloney. So this is the sad part. Does anyone remember Christopher Maloney? Yeah, no, exactly. I was a bit like, I sort of remember this guy. Oh, when you search him on the internet, it's bad. Like, he got a lot of backlash. People just seemed to take a huge dislike to him. And unfortunately, the internet followed. And we all know how brutal people can be behind a keyboard. And they certainly did this to Christopher, which is a real shame. And he actually quit the competition at week 10 and didn't end up carrying on. He was actually quite a good singer when I was watching some YouTube videos. He wasn't really bad. And interestingly, he massively skewed my algorithm as well. He always came out at the bottom. Were the votes still showing this? Was the interesting thing. And actually, some of my weeks, he was at the bottom. So people weren't voting for him because it's a popularity contest, right? So that was super interesting to just see. But the numbers really messed up my my formulas, my ranking formulas for a while, because I was like, gosh, it's like so negative. He's like off the graph sort of thing. What am I going to do about that? So again, data sanity. All of this stuff was done in the aftermath of me building the machine learning algorithm. What does this one mean? Guess. So on the left, gold standard data, we call it, and I had the Twitter data. My gold standard data was at the actual percentage voting per person every week of the competition. You can get it, it's all open data sets apparently. So I had this table and it told me each week everyone ranked by their percentage of the competition. So this was my gold standard, right? This was what actually happened. What happened on Twitter was often a little bit different. Why might that be? When you vote, you have to pick up a phone, you have to be able to pay for that call. You're potentially, I mean, when was the, I think I voted once, and God, I should not be sharing this. I voted for Gareth Gates in Pop Idol, and I asked my mum really carefully, I was like, please, can I vote for Gareth? I want him to win. He didn't. Will Young won, didn't he? Damn, wasted my £1 or whatever it was. But the interesting thing here is who votes? Are they different people to who tweets? Probably a very different demographic, right? The people on Twitter might be much younger. So was the skew in the data showing a demographic? Was the skew in the data showing that actually, yes, these people voted, yes, Ella went out. Did Ella go out because all the young people liked her, if that was what it was that was different on Twitter? Because all the tech people liked her? I don't know. This was an interesting one because I was like, actually, I didn't want to like screw up all my research. I was like, it might be this, but look at this beautiful machine learning algorithm. Please mark me on that. But this is a super interesting social impact of the data sets that you use. Do they cover the actual people that you're measuring against? My gold standard set of data was a little bit different. Okay, so everything was focused on the data, right? I got obsessed with the data. I couldn't stop trying to find news articles and relate them to my data set. I was like trolling the internet for X Factor 2012. But this is actually the case in machine learning. I believe, as someone who's building this type of stuff, as someone who is in data science, the data is so crucial, so crucial. It's not the only thing, but it's a way that technical people might be able to make things a little bit better. I would love to be able to take one of my machine learning algorithms and just say, hey, like someone said in a research paper, if I do this to my different variables, and if I just skew them slightly, my alpha value, my beta value, my Q state values and stuff like that, oh, it's all fine now, it's not biased. Unfortunately, I don't think we're going to get this silver bullet anytime soon. Actually, one of the key things is the past data that we learn from and what we've said in all the past are cultural differences, right? The things that are embedded in the data that we use in society. Keeping on the line of text is actually these two examples. Oh, you're going to hear my really loud clicking, that's fun. She is a developer, translated into Turkish. Turkish doesn't have gender pronouns like English does. We don't have I, you, he, she, it, we, you, they. The good example is obviously, she is a developer was obviously one that was related to me, and I was like, no, is it going to do it? It did it. It said he is a developer. Oh gosh, what is happening? And then the one they actually showed in a talk that I saw was he is a nurse, she is a doctor. And it translates it back again. Now is that though because the words that it is learnt from, the examples have all been, in that case, we're slightly skewed as a society. We know that if he is a nurse, there's a little bit of a sort of transient issue where there's not many male nurses. There's not many female developers. We've already spoken about that. Interestingly, I found this. If you actually go to the translation website rather than just a search engine, it did this to me. I was trying to record it, and I was like, God, solve my problem. Came up with different options. It says, I know this is a gender non-specific language. Do you want to say he or do you want to say she? And then it also translated it back twice. And I was like, interesting way to look at it, right? They didn't fix the data. They fixed the UI. They fixed the understanding of the problem. So very, very quickly, a few key takeaways. When I was speaking to Hannah Wallach at Microsoft in the Fate part of our business, she talked a lot about we build security into our systems. Security is in there by design. Security is in there from the start of the conversation. These types of things should be absolutely done in machine learning algorithms. We should be considering ethics as we're asking these questions. But that's not easy. Is my machine learning algorithm ethical? Well, I built like a fashion detector. That's probably not super inclusive because I trained it on my clothes. So if a guy picks it up, it's not going to work, is it? You know what I mean? We all do it. It's unconscious bias. We should work with people of all skills and backgrounds. We're all saying the same thing. I was so worried we were going to come in and we were all going to say completely different things, and I was like, oh no. Different backgrounds, and this will hopefully make us think a little bit more and be like, oh, what if it doesn't work for this small 10%? One thing that shocked me that Hannah said, it didn't shock me, I was kind of really happy that she said it, proof of concept early and test as widely as you can so that we can learn from our mistakes. It's what we do when we're humans. We learn from our mistakes. We learn by trying different things and getting different outcomes. This was a super interesting one because I was like, oh no, but like, what about the brand and what about this? She was like, literally, the only way we're going to solve this problem is to actually work on it. Like say, hey, I've built this thing. This is in testing. Give me your feedback. Share it early. Give me your feedback. You're only going to find those small percentages where things have been missed by potentially getting the small percentages of people to try it. There's also a concept here of actually DevOps, building in structured engineering processes around machine learning products. We're seeing that more and more. There's now technologies out there. Microsoft have some cool stuff around explainability that's literally released last week at Connect, last week at Connect, around our automated machine learning tool. And it's actually going to be able to explain, give you explanations of why things were made, what variables were being used, what parameters were being used, stuff like that. It's one step, it's a baby step. But luckily, if we start to look at different tooling, we might be able to start to explain outcomes. Please go and watch this. NIPS was one of the, I went to NIPS last year in LA. It was fabulous. And I saw this lady, Kate Crawford. She's my hero. She's my bias hero. She did this wicked, and I mean honestly amazing keynote, and she has some incredible research. Please go and watch that. I highly recommend it. Check out Fate at Microsoft. This is where Hannah and Kate work. They are doing some amazing stuff around interpretability of machine learning algorithms, around understanding what the word fairness actually means and how we can measure that, and all sorts of other stuff in this space. And finally, they had a huge element in the AI Now 2018 report. This was released a few weeks ago. Definitely go and have a look at this. The top of this document has recommendations from researchers and people in the industry that we should all start to look at and follow, and just something to keep in mind, right? Something that can make sure that we step forwards into this problem. So thank you very much for your time, and I hope that was interesting. Sorry, I went over by a few minutes.